Good evening, everybody. Tonight we're going to be learning about equations that have one, none, or infinitely many solutions. So by the end of this evening, we're hoping that you'll be able to obtain this objective, that you'll be able to give examples of linear equations in one variable with one solution, infinitely many solutions, or no solutions. Here we go. How many solutions can an equation have? Well, an equation can actually have three different types of solutions. They can have one solution, which is what we just talked about, no solutions or none, or infinitely many solutions. That means any number will actually work. Infinitely many. If I know how to spell that, that would be great. There we go. So let's take a look with only one solution. A linear equation in one variable has one, let's write that in, solution if only one value of the variable makes the equation true. That means there will be only one answer that will be able to work in that equation. Let's take a look at our example. We have 3x minus 7 equals 14. Well, our first step is to add 7 to both sides because we're trying to get the x by itself. So I'm going to go ahead and do it to both sides because this equal sign tells me that they always have to remain equal. A negative 7 plus 7 cancels out and becomes 0. And 14 plus 7 is 21. Everything else on the left side that I have left over, which is the 3x, is going to remain there. And I always have to remember to bring down my equal sign because they always have to remain equal. Now I have 3x equals 21. Well, how is the 3 and the x attached? They're attached through the operation of multiplication. And I undo multiplication using division. So 3x, I'm going to divide both sides then by 3, or the coefficient that's in front of the variable. I don't want to divide by the x because that will eliminate the x on that side, and I need the x by itself. So if I go ahead and divide just by the 3 divided by 3 is a fancy form of 1, and 1 times x is x. So I have to do the same to the other side. 21 divided by 3 is 7. So here is my solution. X equals 7. Therefore, there is only one solution. So what that means is that if I put 7 back into that equation, it will work. Let's try it. 3 times 7, which is the value of x, minus 7 should equal 14. 3 times 7 is 21, minus 7 equals 14, and 21 minus 7 is 14, so it does work. So remember, only that number 7 will work in this equation. Let's look at some other types. Okay, a linear equation in one variable has no solution, or the solution will be none. That means no number will fit in there if no value of the variable makes the two sides of the equation equal. So let's take a look at what that would look like. First thing I have to do is I look at my left side of my equal sign. I have 11 plus 3x minus 7. Do you see any terms here that are like terms that we can combine? Well, we have a constant of 11 right here, and we have a constant of a negative 7 right here. So I can take 11 and subtract 7 and actually get 4 to simplify that. Now I still have a 3x here and I can't put it together with anything because I don't have any other terms with the value of x on that left-hand side. So I'm just left with 4 plus 3x. Now let's take a look at our right side. On the right side, my like terms include this 6x here and a negative 3x here. Remember to always include the sign that goes in front of the number to make sure that you're doing the correct operation. So I actually have 6x minus 3x's. So that leaves me with 3x's. Notice I still have a positive 5 here. This positive 5 I cannot combine with anything because it doesn't have any like terms. It's a constant. So I'm left with 4 plus 3x equals 3x plus 5. Well, let's see if I can go ahead and get all those x's on one side and get all the constants on the other. So if I take this 4 and I subtract it, and I subtract it from this side because they always have to remain equal, I'm left with 3x equals 3x plus 1. Now if I go ahead and try to bring these x's over to the other side, I have to do the opposite, and they're positive x's, so I have to subtract 3x from both sides. Notice what happens. If these cancel out, I'm left with 1 on this side. I bring my equal sign down. Look what happens here. If I have 3x and I subtract 3x, I'm left with 0. So let me ask you a question. Is 0 equal to 1? Well, I hope you're saying no, because it's not equal to 1. So is this statement a true or a false statement? It's a false statement. That means it's not true. 0 does not equal 1. So this is a false statement. So the equation has no solution. What that means is there will be no numbers, not one number that you can think of that you can put in for that x variable that will make that equation work. There is no solution. Let's take a look at our last type. Okay, our last type. A linear equation in one variable has infinitely many. Oh, let's hope I spell it right. I-N-F-I-N, infinite. I can't even think right now. There we go. I hope that's right. Many solutions. If any value, I'm going to circle that, of the variable makes the two sides of the equation equal. Any value. That means it can be any number, and you can shove it into the place of x, and it's going to make it work. And that sounds really crazy, but it can actually happen. So let's take a look at the left side of this equation. Let's combine our like terms first. So I'm left with a 6x here. If you notice that it matches this negative 2x here, because they both have x's. So what is 6x minus 2x? It is 4x. And I still have my constant of a positive 5, so I'm just going to bring that down. And now I'm going to look at the right side of my equation. And I have a constant of 4 here and a constant of a positive 1 here. So that makes a constant of 5 if I put those together. And they're all positive, so it's got to be a positive 5. And I have this 4x that I can't combine with anything because there's no other x's on the right-hand side. Okay, now let's look what we have left. We have 4x plus 5 equals 4x plus 5. They're equal to each other. So what does that mean? Well, if you want to go ahead and solve it, we can try to do that. If I subtract 5 from both sides, watch what happens. Those cancel out. I'm left with 4x equals 4x. Still, they remain equal to each other. Then, if I try to bring these x's over to the other side and I subtract 4x from both sides, I get 0 equals 0. So still, those numbers now equal each other. And what that means is when you are left with two sides of the equal sign that are equal to each other, it means that first of all, it's a true statement because 0 does equal 0. And what that means is that you will have infinitely many solutions. Oh, I'm not spelling that right. Infinitely many. I don't think I'm spelling that right. Solutions. When you solve for the variable, you get a true statement. What that means is I can stick any number in place of x, and it's going to make the two sides of this equation equal to each other. Do you want me to give you an example? I guess I will, just to prove it. What if I took the number 100 and shoved it in there? Well, that would mean I'd have 6 times 100. And I'm just going to write above this x equals 100 because I'm just substituting that in to see if it actually works. So I have 6 times 100 plus 5 minus 2 times 100 should equal on the other side 4 plus 4 times 100 plus 1. Well, let's see if it works. 6 times 100 is 600 plus 5 minus 2 times 100, which is 200, should equal 4 plus 4 times 100, which is 400, plus 1. 600 plus 5 is 605 minus 200 on this side equals 400 plus 4 is 404 plus 1. Well, guess what? 605 minus 200 is 405. Sorry, my brain's not working. And 404 plus 1 is 405. Look at that. They do equal each other, so 100 works. I could shove any number in there, and it's going to work. Let's try some examples. Okay, we're going to try these equations, and we're going to see if they have one solution, no solution, or infinitely many solutions. First thing we do here is we take our number on the outside, and we have to work through the parentheses using the distributive property. So I have a 3 that I'm going to multiply first by the 2g, and then by the positive 4. 3 times 2g is 6g, plus 3 times 4 is 12. On the other side, I'm just going to rewrite the 6g plus 9. Now I'm going to go ahead. I'm going to try to get all my g's on one side. So these are positive g's because there's no sign in front of it, which means they're positive. So to undo addition, I subtract to zero them out or do the inverse operation. So 6g minus 6g is, guess what? 0. They zero out. 6g minus 6g on this side, bam, they zero out. And I'm left with just 12 on this side, my equal sign, and a positive 9 on this side. Well, does 12 equal 9? Hopefully you all are saying in your heads, no, they are not equal to each other. So this first example has no solution. Now let's take a look at this example. Once again, I'm going to start with the 4 on the outside of the parentheses. I'm going to multiply it by everything inside of the parentheses. So 4 times n is 4n. 4 times a negative 2 is a negative 8, and I'm bringing down my minus 1, equals 5n minus 9. Let's combine our like terms. I have a constant of a negative 8 and a negative 1. Negative 8 minus 1 is negative 9. I'm just bringing down my 4n. 5n minus n, because these are like terms on this side of the equal sign, is 4n minus 9. Oh, look at that. What can you tell me already? Both sides are equal to each other. As soon as you see that this side is equal to this side, that means you have infinitely many, I still don't think I'm spelling this right, solutions. Because that means any number will work. I can shove any number in there and it will work. Let's take a look at one more example. Okay. First thing I'm going to do is my distributive property. I'm going to multiply negative 2 times x, then a negative 2 times a negative 3. So I have negative 2x, negative times a negative is a positive, plus 4 equals, and on this side I have x plus 4 plus 2x plus 16. I can combine the 6 and the 4 on this side because they're both constants, and I get negative 2x plus 10. On this side, I can combine my x's. I have an x plus a 2x, so that gives me 3x. And I have a constant of 4 and a constant of 6, so that's plus 10. Now I'm going to go ahead and get all of my x's on one side. So I'm going to add 2x here because that was a negative 2x to start, and I'm doing the inverse operation. So I'm left with 10 on this side because those zero out, equals 5x plus 10. I'm going to go ahead and subtract 10 on both sides. And I'm going to get 0 equals 5x. So then I'm going to go ahead and divide by 5. Now, right now, what I want you to do on your calculator, because you may not understand this, is I want you to divide 0 divided by 5 and tell me what you get. Hopefully you get 0, so guess what your answer is? Bam, 0. So x is equal to 0. So how many solutions are there? One solution. All right, my friends. I hope this helps you out. We'll see you tomorrow. Have a great night. Is it F8? 10.